I'm Ludwig Pummer. I'm a principal production engineer, and I've been working on Pulsar since its inception.
Hello everyone. My name is I'm a senior principal, the developer. I've been working with Pulsar since beginning in Yahoo. I'm co-creator of Pulsar and lead messaging developer for the messaging team. I'm also lead developer for Sherpa, which is a low latency key value distributed store in Yahoo. So we have been running Apache Pulsar in Yahoo for last 8 years, and on various hardware configurations with various storage devices in our on-premises environment. However, with a huge shift towards the cloud, many companies, they are moving their applications on cloud where they have a need of messaging system for their pub/sub use cases. There are multiple solutions already available on cloud for the messaging, but it's really important to understand the key challenges which you need to consider before you use or deploy any messaging system on the cloud. And you also need to understand the important metrics which would be the right measurement, or it would be the right point to evaluate any messaging system for your use cases. So in this talk, we are going to talk about those critical challenges and the important metrics. And we'll also share why Apache Pulsar was a clear winner for us, for our use case, for our company, and for our users. So before we talk about those critical challenges, let me talk about the Apache Pulsar's footprint in Yahoo. So Yahoo has one of the largest Apache Pulsar cluster in industry. We developed Apache Pulsar in-house in Yahoo in 2014, and since then we have been using for last 8 years. We have deployed Apache Pulsar in 6 different colo around the globe with full mesh applications. In production, we run many different use cases. We have use cases which are latency sensitive, where they have P99 latency 5 millisecond for write. And we are also running many mission critical use cases like finance, Sherpa, mail, sports, news, and many more. The interesting thing about all those mission critical use cases are all those use cases, they run on a same shared Apache Pulsar cluster. It means they are using the same shared resources, which shows the true multi-tenancy nature of Apache Pulsar. However, multi-tenancy always comes with a lot of requirements and a lot of responsibilities like security, scalability, cost management, how to prevent against noisy neighbor issues, and many more. So we really have to understand those key challenges. So let's talk about those key challenges. The first thing we need to decide when we use any messaging system in the cloud, that would be whether you want to deploy that service as a managed service, or you want your user to sit in the front seat and let them make all the hardest decisions, like what should be the hardware configurations, how many servers will be required. If each team is managing their own cluster, then every team needs to build the expertise to run or understand the messaging system, which is definitely reduce their productivity. Or you have another options where you deploy as a managed service and let your user have all the messaging fun without building any expertise. However, managed service always comes with a security issue. How do you create a secure connectivity between the broker which are deployed in the cloud and your client applications which are deployed in different cloud or different user accounts or on-premises environment? How do you make sure that you provide network and the storage security? How do you make sure you provide highest performance without compromising the availability and the durability? How do you do the cost management? So all are the key challenges which you need to consider before you deploy or use any messaging system in the cloud, and you need to make sure the messaging system which you are going to decide that should solve all these critical challenges. Other than these known challenges, you also need to consider the important metrics which should be part of your evaluation book. So in this talk, in next few slides, we are going to talk about those important metrics like managed service, how you have to do the deployment, monitoring, availability. The most important is the cost. So we are going to talk about those metrics, and we're also going to talk about how Apache Pulsar works with all those metrics and our experience with Apache Pulsar. So let's talk about one of the first important metrics, which is the managed service. So Apache Pulsar is the best candidate for the managed service. It's because of its true multi-tenancy nature. Multi-tenancy means you can run multiple use cases on a same shared cluster. So in production, we run latency sensitive application which have latency P99 5 millisecond. And we have another use cases which perform cold reads, the random cold reads from across multiple topics. So when you try to do a random cold reads across multiple topics, that will lead your storage system towards IO thrashing. And eventually that will cause page cache, swap in, swap out, and eventually degrades the entire performance of your storage devices. And as soon as it hits that degradation of storage device, you will see the high write latency. So your latency sensitive application, which have SLA for the low latency, they will start seeing the high latency just because of other use cases which are doing the cold reads, the random cold reads. Apache Pulsar has solved this issue with this unique IO isolation architecture. As you can see in the diagram, in Bookkeeper, it uses two storage devices. The first is journal, which is used for a write-ahead log, where Bookkeeper always performs the sequential write. It never performs any random cold reads. And that's why it makes sure that you will achieve the highest throughput with a constant low latency. And then it asynchronously writes the same data to a secondary device, which is called data device or ledger device, which will be used to do random cold reads if any use case would require. So it makes sure that you can run multiple use cases without impacting each other on the same shared cluster. Another important feature Apache Pulsar provides as a part of multi-tenancy is soft and hard isolation. So in cloud, we use Apache Pulsar, or we deploy Apache Pulsar with Kubernetes containers for the compute and EBS for the storage. We create a separate Kubernetes namespace where we isolate dedicated broker and dedicated bookies for every tenant. And in Kubernetes, it gives a capability where you can do a precise cost calculation for every namespace. So with Apache Pulsar in a shared cluster, we have a way to do exact cost estimation in a managed service in a shared cluster for every tenant, for their traffic and for their usage. Other than, another aspect of managed service is secure hybrid connectivity. So if you would like to, so in our use case, our user basically requires a hybrid connectivity between our on-premises environment on the cloud. So if you want to do hybrid connectivity, how do you make sure that your client which are on different cloud can securely connect to the brokers which are deployed in the cloud? So to perform or to achieve this thing, your messaging system should have two capability. The first, it should support the enterprise-grade proxy solutions like ATS, Nginx, HA proxy. So with recent enhancement in Apache Pulsar, it supports SNI routing protocol, which is a layer 4 TCP routing protocol. And most of the enterprise-grade proxies, they can support this SNI routing protocol. So we can use those enterprise-grade proxies as a forward proxy and the reverse proxy in our Apache Pulsar cluster. Another important thing, or the second capability it should have, would be the synchronize the metadata, policies, or ECL information across two isolated cluster. So with a recent enhancement with PIP 136, Apache Pulsar has capability where brokers, they are deployed on two different isolated clusters. They can share those policies, ECL information, metadata without sharing the global metadata store. So Apache Pulsar provides a great managed service experience, and your user can have a messaging fun without understanding or building the expertise about the messaging system, and they can focus on their business goals. Another important metric is availability and the performance. So availability is another key challenge on the cloud, and Apache Pulsar provides the highest availability, even though the topics, primary and the replica can go down at the same time. The question arises, how? And the answer is, it's because of its unique segmented oriented architecture. So as you can see in the diagram, Apache Pulsar writes the topic metadata into the segment. And Apache Pulsar creates a segment with a set of available bookies, which is called ensemble. If one of the bookie goes down from that ensemble, then broker immediately closes that segment and immediately opens a new segment with a new set of available bookies and continues the write. So it will make sure that your system would have highest availability even though any bookkeeper goes down at any time. For the durability, on cloud, we use or we deploy Apache Pulsar with a combination of Kubernetes for the compute and EBS for the storage. So Kubernetes, if any bookkeeper port goes down, Kubernetes makes sure that bookkeeper port is always scheduled with the same EBS storage device. It means bookkeeper can store the durable data into the EBS storage device, and it can also recover from the EBS storage device. That makes Bookkeeper entirely stateless, which means our durability is basically on EBS. So it means in cloud, we are getting the highest durability with the Apache Bookkeeper's architecture. So availability, performance, and the durability, that are most important metrics to make sure that your customer or users have that confidence to make sure that their application will get the SLA without having any traffic interruption. Another important metric is effortless deployment. It is really important to have effortless and easy deployment to keep your operation team happy. And effortless deployment directly depends on the smooth or simple rollout upgrade without impacting the availability and durability. So in the previous slide, we have seen that Pulsar's unique segmented oriented architecture makes sure that you always get availability no matter what happens if you do any kind of deployment. And with the EBS storage, you will get the highest durability at any point. So you will have a smooth deployment where you will never have any availability issue or the durability issue with any kind of deployment. So that will make a kind of a dream, I would say, the smooth and dream rolling upgrade or experience for your operation team. Other than deployment, in Pulsar will soon have a blue-green cluster deployment handling. It means if your operation team would like to migrate the live traffic from your existing cluster to a brand new cluster. It means generally it happens when you want to upgrade the Kubernetes cluster where you have to destroy the entire Kubernetes cluster and you need to migrate the traffic to the another cluster. So with PIP 188, you will see that Pulsar will have that capability where you can migrate that entire cluster without having any impact in availability and the durability as well. Other than that, for us in our legacy application, we also wanted to migrate our legacy application where we didn't have opportunity to touch those applications because they are in maintenance mode. So to migrate towards the cloud, we required to have some kind of broker side magic where we can create a custom topic. We have the custom creation topic mechanism, and we can basically perform the server side magic and migrate those legacy topics. So with PIP 100, it was possible for us to do that very smoothly. Another important metric is cost. That would be always important metrics for any organizations or for any user. In cloud, we have multiple solutions or multiple options available to choose your compute and your storage to achieve performance, durability, and availability. As we have explained in previous slides that we are using Kubernetes and EBS storage device to deploy Apache Pulsar in the cloud. EBS storage device always makes sure that you will get highest durability, and EBS are really very cost effective compared to any storage device you pick in cloud, specifically on AWS or any other cloud. So with our deployment in cloud, we are able to achieve the highest durability in most cost efficient way. But what about the performance? Because we require all three: performance, durability, and cost. For the performance on AWS, we choose GP3 EBS storage device. So that's because of GP3 storage device gives us the flexibility to provision GP3 volume with a desired throughput and desired IOPS if they are configurable. So we use GP3 for our journal and the ledger device both, and we can actually achieve most cost efficient way because GP3 gives us in terms of the cost, it's way cheaper than any other local storage or any other EBS storage device like IO1, IO2. So we can actually achieve highest throughput, highest the low latency with the most cost efficient way. So we have performed like production setup like a scenario like a performance test where we were having a mutual TLS enabled for the encryption over the wire. We had disk encryption enabled, encryption at the rest. We were doing the tail reads and we were doing the random cold reads, and we were able to achieve our P99 latency between 5 to 8 milliseconds, and the entire setup was less than, like, it was 7 times cheaper than the managed service Kafka, which is already available on AWS. So that gives us our users and our operation team a huge motivation to choose Apache Pulsar for their messaging need because they were getting the highest performance by paying a really less cost. It was so much cost effective. So these are like operational reasons why we have chosen Apache Pulsar. What about our user perspective, why they should use? So I would like to invite Ludwig to talk about it.
Thank you. So Rajan gave some reasons why a platform or a service should run Pulsar in the public cloud. Now I'm going to talk about why an application or tenant would choose to use Pulsar. The first is security, and I'm referring to the security of the connection between the application and the Pulsar platform and the safety of your data against interception. Pulsar supports mutual TLS and uses it for both transport and authentication. Each application or even application component can have its own authorization principle, and that's the common name of the TLS client certificate. I'll go over why this is useful when I talk about authentication in later slides. I need to go into SNI routing because that's a really critical part of secure communications. So I'm going to give a brief explanation of how SNI routing works and how it's used in Pulsar's proxy support. So SNI refers to a TLS extension which lets the client tell the server at the very beginning of TLS negotiation a server name that it wants to connect to. This can be used for lots of things like routing an HTTP request to the right server or serving a specific TLS server certificate. An SNI routing proxy uses the server name indicator to decide which origin to connect to. In this example, the client adds the proxy. In this example, yeah, it adds the proxy service URL in the client builder. And so then the SNI proxy understands this to be the service address. So it looks up this server name in its own mapping table, and you'll see that in the next slide. And it recognizes that this is the cluster service address, and so it picks that and determines that to be the origin, and it makes that connection to the origin. So that makes that with a second TCP connection to the origin, and it proxies all the bytes between these two TCP connections, and it does not terminate TLS itself. So this means that you have a single TLS connection between the client all the way to the broker, and it's handled via two TCP connections, but the key thing here is it's a single TLS connection all the way through, end to end. Here's an example of how you would define the SNI routing rules with Apache Traffic Server. So we have a cluster on cloud in the cluster designated US West 2, and we have like an on-prem cluster designated NYC. So the brokers, in this setup, we use SNI proxying to route between data centers at either end. The brokers on either end are always configured to use their local SNI proxy when they're replicating to the other cluster. And you'll notice there's a pair of definitions for each. We have both the cluster. We have both the. I think I reordered these. We have both the cluster address, which is, for example, the service URL, and then we have we have the cluster address, which is the service URL, and then we have the broker address for local communication. And then for remote, you can see both the cluster service URL and this matches the broker names. These both map to the remote SNI proxy. So we need to route traffic destined for the remote, for the cluster service URL to serve metadata and topic lookups, and then once the topic lookups return a broker hostname, we need to then route the traffic for that specific broker hostname as well. I have a diagram for this configuration in the later slide. So back to secure connectivity. So here's an example of how two clusters connect securely. We have a VPC pairing set up between the Pulsar clusters. Each cluster has a network load balancer in service, Kubernetes service, which is backed by SNI proxy pods running Apache traffic server. The brokers in the local cluster have a replication to the remote cluster configured to use the remote SNI proxy. Since we're using VPC peering, our traffic is off the internet. We don't need to worry about, we don't need to route to the local SNI proxy in this case because we're using the VPC peering. Here's an example of an on-prem cluster replicating with a cloud cluster. So this is a situation for the SNI proxy configuration that I shared before. Because this is going over the internet, we first route to the local SNI proxy, and then it routes to the remote SNI proxy, and we can use network ACLs and firewall rules so that the two SNI proxies only accept remote connections from each other. Next. Okay. And then finally, as a user, this is how a cloud tenant would connect to a cloud Pulsar cluster. In this case, we create a private link service in the Pulsar cluster, and then the user creates a private link endpoint in their private subnet, and they configure their Pulsar cluster to use SNI proxy, and the endpoint being the host name of the private link endpoint in their private subnets. The use of private link simplifies routing, network ACLs, security groups, and it keeps all this traffic off the internet, and it doesn't expose the SNI proxy to the internet. Okay, I've covered how Pulsar in the cloud offers secure transport of your data from your application to the Pulsar cluster and also between Pulsar clusters. Now back to some of the other reasons why users would choose Pulsar on public clouds. So Pulsar on a public cloud service inside a Kubernetes cluster gives amazing availability. As a user, you don't need to worry about cluster maintenance. You don't need to worry about releases or rebalancing because of how Pulsar is architected. And because you're on the cloud, you don't need to worry about host failures. Your data is on EBS, and it can get remounted to any pod. Your capacity is managed by Kubernetes, so pods get replaced or added automatically. Pulsar also has very strong persistence guarantees, by default requiring an fsync on 2 different EBS devices before acknowledging the publish. In the cloud, writing to mounted block storage, which has greater reliability than local disk. And latency on EBS is pretty good too. Rajan mentioned 8 milliseconds with GP3 journals. With IO2 journals, you can get 6 milliseconds, but they cost more. But this is also accounting for encryption at rest on your EBS volumes. Pulsar on Kubernetes on public cloud costs about 1/7 of what managed service for Kafka does. You can get the price down even further by taking it out of Kubernetes and managing the base instances yourself, but it's probably not worth the operational effort to run that way. So I talked before about transport security. Pulsar offers also a great deal of control over access to your topics and your messages. Pulsar's implementation of end-to-end or envelope encryption is multi-tenant friendly, and different topics and messages can even have different keys, allowing you to control precisely who can ultimately decrypt the messages and access your data. As a user, you can control who connects to your topics on the granularity of namespace, topic, or even subscription name. And if you're using MTLS, you authorize based on the client certificate's common name field. So I've covered security of transport and some of the security of data at rest. Even if you don't use end-to-end encryption, running Pulsar in a public cloud means you can use encrypted block storage, and it's a whole lot easier to manage than on bare metal and data center from my experience. Pulsar's geo-replication and hybrid access means that as a user, expanding your Pulsar cluster, Pulsar-based application to a new region couldn't be simpler. Once the Pulsar cluster has been created in a new region, whether it's on cloud or on-prem, you run one Pulsar admin command, and suddenly your topics are available for use in the new region. And thanks to the SNI proxy feature built into the Pulsar client, the only thing you need to change in your application to use the new cluster is 3 connection parameters: the service URL, the proxy service URL, and the proxy scheme. So in summary, running Pulsar on public cloud is a compelling option. Running it on Kubernetes cuts your operational resources needs significantly. Utilizing MTLS and public cloud's networking and storage features, you get strong security in transit and at rest. Durable publish times are single-digit milliseconds at a cost that's a fraction of managed service for Kafka. And your users and Pulsar clusters can run any combination of on-prem and cloud, public cloud regions. All these make for happy platform operators and happy customers.